Okay, here in this video we will try to explain what derivatives is all about. I want to make an introduction. If you had read about it in books and calculus, don't think that the derivatives is natural or intuitive. No matter how much the books will tell you, think about it like science fiction. It is, we have, God gave us a tremendous amount of imagination, and we can explore and think in all kinds of different weird and cute and creative ways, and that is calculus. It's actually very creative. It's a very close relative with science fiction, but it's just much more creative and more interesting, not so boring, I would say. It is seeing the cleverness that God gave in our minds. It's definitely not intuitive. Again, it's not meant for a 10-year-old kid. Do not try to explain it. You can explain what 10 plus 10 means. 10 chocolate bars, another 10 chocolate bars. You explain what fractions is, a little bit harder, but he understands. You can get a quarter of a cake, a third of a cake for 3. All these things, they give you stories in the books, and it's, you explain it here, you explain there, you explain multiplication, division, you have all kinds of examples. It makes sense. This is an abstract thing. Yes, abstract. There's such a thing. Our minds are wired in a way we can think very abstractly. That's why we are Tselem Elokim, the image of God. We think in very abstract forms. This is an abstract thinking. Let me start with the most non-abstract, or I would say the easiest kind of story here. Again, it's science fiction, but at least you can use imagination. Why not? We have a car. Okay, a car is quite natural. A kid knows what a car is, a bicycle. We have a car, and we also know such a thing. A car can go, you can go fast, you can go slow, right? You can go 60 miles per hour, on some highways. You can go 40 miles per hour, 30 miles per hour. This is, I think, quite natural still. Every kid understands that you can go fast, you can go slow. You can even you can tell, I think, for an 8-year-old kid what means 30 miles per hour. It means I'm going at such a speed. He knows what means speed. He can go with his bicycle very fast or slow. It's a very natural thing what speed is. And you can tell him, hello, right now we're going at a speed of 30 miles per hour. It means if we continue with this speed for a full hour, we will be traveling 30 miles. Okay, the child is going with the father upstate New York to the country. He sees another 200 miles, and the father tells him we're going now 60 miles per hour. So the kid is a little mathematician. He says, oh, it means in 3 hours and something will be there, because 3 times 60 is 180. So we'll be there 3 hours and a third. The father says, yeah, but soon might be traffic. Might be going only 20 miles per hour. So the kid understands that it's a very nice conversation in the car. I think everybody can talk. It's very good to tell this to your kids. Definitely, even this, you need some kind of talking. But I think the kid will easily think, he pause a moment, will think of, and then he say, Tati, oh, I understand, I got it. So 60 miles per hour doesn't mean the next 60 miles will travel 60 miles per hour. It means right now we are at a certain speed of 60 miles per hour. It might change if there's an accident, so we might be traveling at 5 miles per hour. So the whole 60 miles per hour is gone with the wind. It's it was just for the first, we had just a nice few minutes that we went 60 miles. So I think this will be a nice discussion. It's important, and I'm underlining this. Important to talk with your children, open their minds, let them explore. God created their minds, let them use it. Talk to them, open their minds. Very important. First blessing we pray is Hashem should give us intelligence, understanding is the biggest blessing, so let them have the blessing. Now, here is where it gets a little bit weird, as I call it gets some fiction. Imagine you have a program in the car. It works like this. It works that you have a clock, and we make the car should always be such a distance from the starting point. So you start in New York City, it should be the time squared. You know what squared means? It's a certain operation, it's math. You know what squared means. 4 times 4, 5 times 5, 25, 6 times 6 is 36, 2.5 times 2.5 is 6.25. We know that squared is a function that is described on all the of the number line. Anything you can square it and you get something in return. There's no reason why you can't square any single number in the world. Actually, it is defined also as the area of a square. Take that line. So squared is it's also not so natural. But anyway, there's such an operation, it's called squared, and we take it for granted. You don't see it go to high school, you know. It's on the calculators, so you start to get used to thinking that such a thing exists actually, of squared. So here we take this unnatural thing of squaring things. We take it, why not? And we say that this car, this also unnatural car, this fictitious car, will always be exactly the distance, will be time squared of the time. So let me explain. So if the time right now is, I'm going to go now with minutes instead of hour. So if it's the unit of measure will be minutes. If it's 1 minute past, it will be exactly 1 mile away from New York City. Let's say we have a specific point where we call that's going to be the starting point. The car starts driving. This automatic car, this fictitious car. If it is 2 minutes, the clock. He starts driving. He has a clock, and the car keeps on moving. When the clock will show 3 minutes from departure, it will be 9 miles away from the starting point. When the clock shows 4 minutes, it will be 16 miles away. That's how the car works. Don't ask me why. It's a magical car. It will always be the amount of the minutes squared. That's how much it will be the distance from the starting point. When it is 10 minutes on the clock, it will be 100 miles from the starting point. Interesting car. So here somebody is riding in this funny car, and he is thinking to himself. He's sitting in the car, and while he's enjoying this funny ride, at one point he sees on the clock 7 minutes. He's asked himself, what is my speed right now? How many miles per minute am I traveling now? Interesting question, right? It's quite a confusing question. He knows he traveled 49 miles from starting point. He also knows that when he's going to be on the clock 8 minutes, he's going to be 64 miles from starting point. So he thinks in his mind he's some kind of roughly estimate. He says, hey, look, I'll be traveling from 7 to 8 minutes from 49 to 64. That is 15 miles. So roughly I'm traveling 15 miles per minute. Sounds quite reasonable, right? He knows, again, he knows right now the car traveled 49 miles from starting point. When there's going to be 8 minutes past, I'll be 64 miles away from starting point. So in this minute from 7 to 8, I'll be traveling 15 miles. So that means I'm traveling 50 miles per minute. Then his friend sits in the car. He says, I want to add something. How about like this? When you were 6 minutes away from traveling from starting point, the clock showed 6 minutes, you traveled 36 miles. When the clock shows 7 minutes, traveled 49 miles. Let's do some math. What's 49 minus 36? That is 16. So he concludes that you're traveling now 16 miles per minute. So again, we have some kind of contradiction or some kind of argument between the two friends in the car. One guy says, let's take 8 minutes, 7 minutes. By 8 minutes will be 64 miles. By 7 minutes will be 40. By 7 minutes we are actually 49. Right now is exactly, the clock shows now 7 minutes. So we take, in this next coming minute, we will be traveling 15 miles. So he concludes from this that right now, at this moment, we're traveling 15 miles per minute. Sounds good. The other guy says, no, let's look backwards. When the clock showed past tense 6 minutes, we had traveled at that time 36 miles. Right now, when the clock shows 7, we traveled 49 miles. So it means in this past minute, from 6 to 7, we have traveled 13, I said 16. 13 miles. 13 miles. I said before 16, my mistake. It's 13 miles. So the third guy says, oh, you know what? I'll be the third one to make the compromise. I guess it's not 13, it's not 15, it's 14. Okay. Everybody's happy. But it's nice, and it's, by the way, it's true, but this third guy said, but just by chance, by luck. It's not always true. It just works out here, in this case, to be true. But here comes a deep question that needs a lot of thought. Is there a legitimate way how to calculate, how to answer this question? These two guys are sitting there. They're just shooting out answers off their sleeve, not giving it too much thought. They're sitting in the car, in this weird car, they can't think too deeply. Can we sit down in a room, relax, and take apart this situation? I'm telling you, I know it's not a real life situation, that's why we have no patience for it, because it doesn't really bother us too much. But just as an exercise for the mind, can we take this question apart and figure out some kind of way of finding out exactly when the clock shows 7, at that moment, at that time, how fast is the car traveling at that point. That is the whole idea of derivatives. That can be done. That is a very interesting, it's a big novelty that was discovered by Newton, Leibniz, that it could be solved. And not only with this particular function of x squared, by many, many functions that are known to us. Example, our functions, logarithm, sine, cosine, all these functions that are known to human beings, to humankind, to mankind, that were created by inspection. All of those have certain tricks how we can figure out the derivative, means the exact rate of, here we have time is one thing, distance is the other thing. We want to know how at a certain point, what is the distance per time, not in from 7 to 8, not from 6 to 7, exactly by 7, what will be at that point a tiny change in time, what will be the change in distance, how many miles per distance, per unit of distance. So I'm just giving an introduction. You just try to imagine this. You take a very small, try to do this exercise. Say hello. By 7 minutes, I'll be traveling 49 miles. By 7.0001 minutes, I'll have been traveled 7.001 squared, whatever that number comes out. Now, see the relationship in a very close number to 7, how many miles per minute the guy is traveling. Obviously it's not a full minute, it's a 0.0001 of a minute, but how many miles per minute is he traveling? So you can figure it out, because you know how many miles per 0.0001 minute, so you know how many miles per minute. And you start seeing a pattern the closer you get to 7. You see somehow that it zooms in into a particular specific number, how many miles per minute. It's magical. That's what happens. It gets somewhere where you realize the more 0.000001 you're adding, the closer you get to that relationship, how many miles per minute. And here it's going to be the number 14. You want to prove it to yourself, just take a calculator and make 7.000001, make that many zeros your calculator can handle, times 7.000001. That's going to be 49.00 whatever. Now take the deduct this 49.000 from 49, you get a certain decimal. Take that, divide by 0.0001, that number will be 14.0000, very close to 14. The more zeros you add, the closer you get to 14. You'll never get below than 14. that means that the answer is 14. This is a very rough sketch on derivatives, a very simple, not getting technical, not trying to get with all these fancy words with limits, all these words and words that they might be helpful, they probably are helpful, but first we need to get a feel. This is an introduction. As people that never even enter this field, just to get a feel, what is this all about? The answer is, I'll repeat, it's about using science fiction. That's what it's all about. It's about imagining a certain things, two things that are continuous. That is time is one thing that keeps on ticking, the clock, and also distance, the car keeps on traveling, and then trying to see the relationship between time and distance. And in the fictitious part is that we have to imagine that the distance keeps on changing according to time. This is a very weird thing, that when a car traveled 5 minutes, it went 25 miles. 10 minutes, so on. So this is the weirdness of it. But think about it, please. Think about it. When you sit in the bathroom, think about the car. And think about the question. And the more thought you get about it, the more you understand it. Thank you for listening.